Hey everyone! If you're a student struggling with chemistry, you're in the right place. I'm Lila, a current high school student whose goal is to help other students understand chemistry concepts by breaking down lessons into short and easy videos. Let's get into today's video. Today, we will be exploring Boyle's law. This law shows and explains the inverse relationship between volume and pressure. When a gas experiences a decrease in volume, the particles have less space to move around, resulting in more collisions with each other and the container's walls. More collisions will lead to an increase in pressure. The general formula for Boyle's law is that at a constant temperature, the pressure of a gas is inversely proportional to its volume. When you are solving problems or equations relating to Boyle's law, you will need to understand these formulas. To better explain these formulas, I'm going to provide an example problem as a visual. The first thing you need to know is that whether you are finding a new volume or pressure, you will need to figure out the old variable and the necessary adjustment. The old variable will most likely already be given to you, although in some cases you may have to work backwards to find the old variable instead. In this example, we are given the old pressure, new pressure, and old volume. We are solving for the new volume. To start any problem, I like to write out my variables on the side like this. And then I'm going to fill in any information that I'm already given. Now I'm going to set up the foundation for my equation. This will be the same setup for any problem. I am going to fill in the first blank with the old number of the variable I am solving for. So in this case, I am going to write 250 milliliters because I know that I'm solving for the new volume. Remember to always write your units. The next part is a bit trickier. Since we are solving for volume, we need to find the pressure adjustment. It is crucial to understand the relationship between volume and pressure to figure out the adjustment. These variables have an inverse relationship, so I know when one increases, the other will decrease. Because I am given both the old and new pressure, I am able to observe that the pressure is increased. Since my pressure increased, I know my new volume is going to decrease and will be less than 250 milliliters. When you are given a Boyle's law problem, you are always going to fill in these last two remaining blanks with the information of the variable you are given and are not solving for, which for this problem will be our pressures. Unlike Charles's and Gay-Lussac's law, you aren't necessarily going to put the new variable on the top and the old variable on the bottom. If you have observed that the variable you are solving for is going to experience an increase, the larger number of the other variable will go on the top. If you have observed that the variable you are solving for is going to experience a decrease, the smaller number of the other variable will go on the top. In our example, we know the volume is going to decrease, which means the smaller pressure of 720 millimeters of mercury is going on the top, and the larger pressure of 750 millimeters of mercury will go on the bottom. Now that I have my equation set up, I can plug it into my calculator. Make sure to put the variable adjustment in parentheses to get the correct answer, which is going to be 240 milliliters. Let's try another problem. For this one, we are solving for a new volume again. We are given the old pressure, new pressure, and old volume. Before I start, I'm going to set up my problem. In this first blank, I'm going to write my old volume of 100 milliliters. By looking at my old and new pressures, I am able to see that there was a decrease, which means my volume will experience an increase. Because the variable I'm solving for will increase, I know the larger number of my other variable will go on top and the smaller number of my other variable will go on the bottom. This means 735 millimeters of mercury will go on top, and 700 millimeters of mercury will be on the bottom. Now I can put this into my calculator, which gets me an answer of 105 milliliters. I have one last example for this video, which is going to be a try-it-yourself problem. I will leave the problem up on the screen for a moment, and then we'll display my work and answer. Feel free to pause the video if you need more time. Okay, I'm going to fill in my work and the answer so you compare your answer to mine. If you were correct, you should have got an answer of 1.9 atmospheres and had your equation set up like this. That concludes today's video. I hope that after watching this, you have a better understanding of Boyle's law and the relationship between pressure and volume. If this video helped you, make sure to watch more chemistry breakdowns like this on my channel, and feel free to ask any questions you have in the comments. Thanks for watching.